Hey there, welcome to the video, and here we'll be discussing about some of the best practices that you can use to write better JavaScript code. Think of this as a working session where we'll be starting with a code snippet which functionally works, but it can be made better in terms of its performance, its readability, and the total amount of code that's there. And for that, we'll be going over concepts like concurrency of your asynchronous request, reusability of code, and using destructuring to access the key value pairs from your objects. So let me take you through the piece of code and how it functionally works, and step by step we'll improve it. So here on VS Code, if you notice, I've started a new node project which only has a single file called fetch.js. This particular file defines a function called fetch user details, which is an asynchronous function. So if I hover over this, just notice carefully that it's returning a promise which will return an array of objects once it's fulfilled. And then we're just simply calling this particular function. And since it's returning a promise, we also have a .then block where we're just console logging the data that was returned. Now looking at the function definition itself, this function is using Axios to make 3 API calls. Now all of these 3 API calls are GET requests, which are being made to a user's API which is readily available to us on the web. And if we see what the response of this particular API looks like on the browser, it's returning a JSON response which also has some nested objects within it. To fetch users with other IDs, all we need to do is just pass in the other ID. So if we give ID2, we're getting the details of the user with ID2. And we're calling 3 of such APIs here in our function. And since they are API calls, they are asynchronous. And that's why we had to use await in front of all of these API calls. But moving on with the function definition, we're creating an empty array and we're giving it the name result. Then on the next line, we're pushing 3 objects to this particular array, which are separated by commas, and each of these objects have the keys ID, name, and city. And the values for these keys will be coming in from the user1, user2, and user3 objects. And if you see here on the browser, we had ID, name, and then we had city nested inside the address object. And that's why to access the city value, we're saying data.address.cities. And once we are done pushing the results in our array, we're just simply returning the array back. Let's go ahead and run this particular script and we'll see what response we're getting back in the console. And obviously, since this is a node project which is using an npm library, we have to run it using the node environment itself. So I'll say node fetch.js and hit enter. And after some time, as you can see, we're getting a response back, which is an array of the details of 3 users. Now let's try to improve this function. And the first and foremost thing that we should be working on for any function is its performance. Right now, the most time-taking operations that are happening are these 3 API calls, and all 3 of them are asynchronous and happening one after each other. But if you notice one thing here, these API calls are independent. Hence, even if these API calls were happening parallelly, we would still get the same result from our function. And this is the first and the biggest mistake that this function is making, that the API calls are not happening concurrently, even when they can. So before we make the calls concurrent, I'll show you what I mean by dependent and independent asynchronous operations. Here in the console, I'll make a fetch call. So I'll call this very API. And since fetch will be returning a promise, we'll have to use the await keyword. Whenever we make a API call using fetch, we have to make another call using .json. As of now, we've gotten back the result, but the result is still just a stream of data. To parse it as JSON, we always call another asynchronous function. So we say something like this, that result.json. And since this is also an asynchronous request, we will add the key await in front of it. Now if we try to see what data variable holds, you'll be seeing the actual response. But in this example, for our second asynchronous operation .json, we were dependent on the result of the first asynchronous call, which was using fetch. So this is an example of dependent asynchronous calls. When you have something like this, obviously it makes sense to wait for the response of the first call and then make the second one. But here in our example, the second API call, which we're storing in user2, is independent of user1. And similarly for the third API call, it's independent of the first 2 API calls. So we can go ahead and actually have these calls being made parallelly. What it will do is it will reduce the execution time of this function here. And let's also add timestamps to see how fast our function actually became by using concurrent API calls. And for that, what we have done here is just when the function starts executing, we're storing the current timestamp using new date.getTime in a variable called start. And at the end of the function, just before the function returns, we're console logging the time taken in seconds by this function. It will give you a rough idea how much time it took getting from line number 4 to line number 26 at least. So let's run our function again. And as you can see here in the output, it took roughly about 1.57 seconds. Now let's run these API calls concurrently. And for that, all I will be doing is removing this await keyword from all the API calls. Now what these variables user1, user2 and 3 are storing is just the promise that this function call returns. Remember that these are unfulfilled promises and we did not wait for the result yet. And hence for these promises to get fulfilled concurrently, I will be using Promise.all. And Promise.all, as you see here on the screen, takes in an array of promises and will return an array of results when all of the provided promises have been resolved. And even if one of these promises fail, the entire promise.all will fail. So here we'll pass an array, and in this array we'll add our user1, user2 and user3 unfulfilled promises. And obviously, since this is a promise, we'll have to await for the results. And this right here is a syntax for concurrently making these 3 API calls here. So all 3 of them will be happening at the same time. We'll make these const to let for now. Just bear with me while I write bad code. We'll be changing all of this in a while. And remember, since promise.all was returning an array, so we can destructure the array result and write the results as. So what this line is basically doing is, it's waiting for all the promises to be resolved and then returning the responses in an array, and then we're destructuring the array here. Now we had to use the same variable name because later on in the function we're referencing to these variables. For now, let's save our changes, rerun the function, and we'll see the amount of time it takes now. So we'll run this function again, and here as you can see it took 0.645 seconds in total, which is almost 3 times as fast from the response time that we were getting when all 3 calls were happening one after the other. So we just proved here that when your API calls are not dependent on each other, it benefits us a lot by making them concurrent. Now the code looks weird as of now, so let's also do some cleanup. The first cleanup that we'll be doing is that since there is a lot of repetitive code around axios.get, we'll create an IDs array and iterate over all of those IDs to make the Axios calls. So I'll create a user IDs array which will have the IDs 1, 2 and 3, and we'll iterate over all of them by using the map method. And for each ID, what we want to return is an Axios call which was made for the particular ID. We'll replace the 1 by a template literal. So here we'll give the $, open close curly braces, and give the variable ID here, and instead of single quotes we'll be using the backtick. So a string template is ready where the ID will be the current ID that's being iterated over. Now this map function here will be returning an array of unfulfilled promises, which is exactly the thing that we were passing to promise.all. So now we can remove these 3 calls that were repeating unnecessarily, and we'll store the array which is being returned from the map method in, let's say, a variable called requests, and we'll pass this requests array to promise.all. And now we can declare our user1, user2 and user3 variables using destructuring. And to prove that the changes we made so far work, we'll run the function again. And as you can see, it's returning the response in the reduced time period. Now, one more thing that I don't like about this function is the way we're writing result.push here. What we can instead do is store the responses also in an array so that we don't have to write this same logic again and again for accessing the value for the key. So here, instead of this, I'll store the result in responses, and we'll iterate over each response using responses.forEach. And for each of the responses, what we need to do is called result.push. Result is our empty array here. So here we'll say result.push, and instead of user1, we just need to put in the variable name response. We again reduce the amount of lines that were there in the function, so we can just completely remove this result.push that we had before. And now our function looks much more neat and compact. And for the last touch of finesse, instead of writing response.data every single time while we are accessing these values from the response object, what I will be doing is destructuring them from the response object. So I'll say const data from response. Now what this line is doing is fetching the data key from the response object, but the keys that we actually need are ID, name and city, which is then present under address. And we can actually access all of them using destructuring itself. The syntax for it might feel confusing, but trust me, once you practice one or two examples around it, you will never access your values like this again. So I'll write a colon and I'll destructure ID, name and address from the data object itself. So it's like destructuring inside destructuring. And the fun part is that you can again destructure address and pull the city key from within it. So from this particular line, three variables will be created, namely ID, name and city. And hence I can now use the shorthand for creating the object. So I can directly write ID, name and city here in the result.push call that's happening. And this is it. This is the last change that I would make to this function right here. And let's run our function again to make sure everything is fine. And damn, our response time has been reduced further. So we just went from 0.1571 seconds to 0.79 seconds, which is a major improvement. Let's run this again to see that, the performance is consistent. So yeah, our function now takes less than 0.6 seconds to execute. And I know for the beginners, what we just discussed in this video might be a lot of new things, but this right here is how an experienced JavaScript developer would write their code. So I really hope that the concepts that I just told in this particular video will help you write better JavaScript code in the future. So please like and share this video if you learned something new. And comment down below if you feel that there can be further improvements to this particular function. It's your engagement which makes my videos reach out to a wider audience and helps me with the YouTube algorithm. And also don't forget to subscribe because I post new videos every week. This was it for the video. Thanks for watching and I'll see you in the next one.